we have created this assembly design. Now let's see how to make this press tool simulation. So this top plate with this guide bushes, it should move up and down direction. So for that, already we have arrested degrees of freedom for single individual parts. Like for example, for top plate also, in this moment we want list movement. So in this direction we have given offset dimension. So now just I'll go with constraints. So we'll check here with offset dimension. This is the offset we have given. Let's delete that. So if this offset is there, this top plate, it won't move up and down direction. We need to delete that. Then just I'll minimize this. So to make it simulation, we need to go here with start, digital mockup. Here DMU kinematics, you can get one workbench. So just we will click on DMU kinematics. Now this is the interface of DMU kinematics. So just I'll drag these toolbars out. So we are able to get vertically. If you hold shift and drag, we are able to make it here horizontally. So just we need here these two toolbars. Then now we are going to make here first option fix. So first we need to fix the base part. So I'll go here with fixed part. Then we are able to create here new mechanism. If you want, we can change mechanism name, or else let it be, no problem. So just I'll keep it as mechanism 1. Let's say okay. Then fixed part, we need to fix this bottom plate. Just I'll click on that. Then bottom plate will be fixed. Now to apply these relations, we need to go here with this DMU kinematics toolbar. Here we are able to see different type of joints will be available for us. So here first we need to go here with rigid joint. Rigid joint is nothing but one part and one more part, exactly it will fix to that and it won't move side by side. So now we need to fix that. So just let me go here with rigid joint. So to use continuously, I will double click on that. We need to fix rigid between guide bush to this top plate. Let's say okay. Again same this bush to top plate. Okay. Then again bush to top plate. Okay. Same like that for this bush to this top plate also we need to make rigid. Now if we move this top plate, along with that guide bushes also will move up and down directions. Now to give that up and down movement, linear movement, we will go here with prismatic joint. Just we will click on prismatic joint. Then line 1 we need to select any this edge we can select. Then line 2 for the second part I will click on this. Then plane 1 I will select on this first part plane. Again plane 2 is this. Then length driven should be turned on. So if it is turned on, then only this top plate will move in up and down direction. Let's turn on length driven and let's say okay. One pop-up it should come as the mechanism can be simulated. If you get this pop-up, then your joints are correct. Now let's say okay. So to check that simulation, so just I'll close this. So to check simulation, under here DMU generic animation, first option we will be having here simulation. Let's click on simulation. Then we need simulation for mechanism 1. Let's say okay. Now we are able to get here two pop-ups. Just if I scroll this part is able to move in up and down direction like this. So here as you can see, this top plate is able to move beyond that limits. Then again it is overlapping to this bottom plate. So to make it proper relations, let me check dimensions first. For example, I need movement up to here. So we are having -20. Then in positive side, we need only up to here. So here 84. Let me consider some 80 here. So to check these limits, just we'll cancel that. Now in specification tree, we need to go for applications. Open here mechanisms. We are having one mechanism. Under that we have joints. Here these four are rigid joints. We need to change limits for prismatic joint. Double click on that. Minus value we want here only 20. Positive side we want total 80. Let's say okay here. Then just I will minimize this. Now again we will click on here simulation. Then for mechanism 1, let's say okay. If I move this, maximum it is moving up to here, whatever we have given limits. Then downside also maximum we given 80, up to 80 only it will be moving. So just I'll move like this, and always try to maintain this cursor on positive side. Then go for insert, animate viewpoint. Here we are able to change movement, like if it is loop mode, only in one direction it will move and it will stop. Second one, two arrows you are able to see here. If we keep like this, it will move up and down direction continuously. Then again, if I click this one more, two arrows we are having on one side, again the same operation will be repeated continuously. Now we need repeated on both the directions, like it should be going upside and downside, like reciprocate motion. Then we are able to change here speed. Let me keep this speed as some 0.02 and let's make it here play. Now as you can see, with the given speed, with beyond this given limits only, this top plate with guide bushes it is able to move in up and down direction like this. So if you want to increase speed, just we can increase the speed also. So this is very fast, so just I'll make it some fast like this. So in this way, we are able to create this assembly design and we are able to give this joints and we can make it simulation like this for better visualization understanding. So thanks for watching. Keep supporting. If any doubts related to this or if any improvements are other than this if you want from my side, so let me know in comment box. Once again, thank you everyone.